Good morning, my dear students. So today we are going to start system programming course. So we will have this course in a medium pace. So I know already you have studied a lot of concepts, but still I don't want it to be very fast because I want the people who have so far not studied system programming or who have not concentrated during the classes will also be benefited now. So we will not be very slow like your normal classes nor be very fast like a crash course. So I want to keep the pace in between, right? So whatever classes we are going to see now will also be uploaded. So once I upload it, I will send you the link, right? Yeah, so here we start the system programming. We will start from the basic concepts. Today we will see a lot of basic concepts. So if you are thorough with what is happening, then every concept you study will make sense to you, right? So let us see. So introduction. First thing is, first of all, you should know what do you mean by system programming, right? So far, whatever you have studied in BCA, this will be the ultimate paper. So I would say this will be the on the top of everything because we have only studied application programming, right? We have only studied application programming. We have studied a lot of high-level language programming. We also studied assembly-level language programming. But whatever programming we studied so far are all application programming only. So we have not studied system programming. This particular paper is targeted to make you a system programmer. So what do you mean by system programmer? You can write your own application or you can write your own program for a compiler. You can write your own compiler, you can write your own assembler, right? You can write your own loader program. You can write, ultimately what you can do, you can write your own operating system. So your operating system, your assembler, your compiler, these are all your system programs, right? So this is not, we are not going to study programming of how I program a compiler, but we are going to study what are the steps. If I have to build my own assembler, how does the assembler work? What are the steps? This is what we are going to study theoretically, right? So that is one thing. In system programming, that is what we are going to study. The second thing is we are going to consider a programming language, right? Though you have studied a lot of programming language, you have also studied an assembly level language 80, 85. But here we are going to use an assembly level language only, but it is going to be IBM 360. Right? IBM 360 is the assembly level language program which we are going to study a little bit. So why? Because it's not a programming paper. We will write a program in IBM 360 and then try to assemble the program. On the way we will see what are the steps in assembling a program. Okay. Same way, what are the steps in macro, what's the steps in creating a macroprocessor, a loader and so on. So we are just going to use this IBM 360 only in the first unit just to write one program. If you just understand that one program, it is more than enough, right? And with that program, we are going to move on and say, how will I convert that program into a machine level language, right? Since I have started this, so what are all the basic things you should know? You should know what do you mean by a system program? What do you mean by a system program? So system program is going to be the program which will interact with the hardware, which can directly interact with the hardware. For example, if I have to write my operating system, it has to deal with all the resources, right? Which means it has to directly be linked with my hardware. So these system programs are the programs which is going to be directly linked with your hardware, right? So let us start. Yes. So first and foremost thing I have kept for you is the difference between system software and application software. So in this first chapter, we will be having a lot of differences. I will just tell you what is the basic concept, and automatically you can prepare yourself for the difference. Right? So system software, as I told you, it is a machine independent software. It is a machine dependent, which means you have to know the internal architecture of the machine so that you will be able to code it. Internal architecture here meaning you should know how many registers are there, right? So these information you know, only then you will be able to write the program. So only then you will be able to write these system programs. So what are the system programs? A compiler is a system program, a loader is a system program, an operating system is a system program, an assembler is a system program, and so on. Right? So these are all system programs. So what do you mean by application software? We have already studied. We have created many application softwares also. For example, an inventory control system. So you're doing a project, right? You're creating applications. All these applications will come under the application software. Right? So whatever programming we have studied so far, it's all going to be application programming, application software only, right? So now also in system programming, we are not going to exactly study the programming, but we are going to study how can I program an assembler on my own, a compiler on my own is what we are going to study, right? Yes. Yes. So before studying what is what, I wanted to tell you, you have 5 units here. Right, first unit is going to be an introduction, second unit you have assembler, third unit you have macroprocessor, fourth will be loaders, and fifth is your compiler. So before moving into that, you should know what is an assembler, what is a macroprocessor, what is a loader, and what exactly is a compiler. Right, so we will also see all those things. Right. So to start with, okay, so there is a very important 2 mark question here in system programming. The first, mostly it will be asked in the first 2-3 questions. So it is going to be components of a system software. In system programming, what are the components? Right? So all the 4 units, all the units starting from 2, 3, 4 and 5, all the 4 units are going to be the components of your system software. So let us see what are the components. First one is an assembler. Right? So you have to tell me what do you mean by an assembler. An assembler is a what? What programming it is? Assembler is a system software. First thing is, it is a system software. It is used to convert your assembly level language programs into machine level language. We have studied that already. Assembler will convert your assembly level language into machine level. Right? Similarly, I will also finish compiler now itself. Compiler will translate your high level language program into machine level. Okay? Assembler will translate assembly level language into machine, high level language into machine will be translated by your compiler. Right? In the end, what is the work of assembler and compiler? It is supposed to translate the source code into what? Machine language or the object code. It is supposed to translate the source code into object code. Source code will be in your programming language, be it your high level programming language or assembly level programming language. Whatever language it is, irrespective of what language you are using, it should all be converted into machine level language. It means zeros and ones. Right? So we will be discussing that in the assembler chapter. Assembler chapter, we will see how a program written in IBM's 360 can be converted into zeros and ones. How do you convert all the instructions into zeros and ones? That is the target of that particular unit. You understand? Yes. So compiler, similarly, what are steps in compiling? How a high level language program can be compiled? That is what we are going to study in the 5th unit, where you have compilers. Right? So that is compilers and assembler is covered. So those are the 2 components. The third component I would like to tell you is the loader. So assembler and compiler, I think you would have studied, maybe when we discuss microprocessor also I have told you. So loader is something which is new for you. Right? Now I wanted to link it to the operating system. So in operating system, how will I execute a program? If I have to execute any program, that program has to be loaded into the main memory for execution. We have studied that in the 3rd semester. So any program has to be executed, has to be loaded in the main memory for execution. Yes or no? Yes, did we not study that? Yes. So what is the work of the loader? The work of the loader is to load the program, whichever program has to be executed, that program has to be loaded into the main memory for execution. Right? So yeah, now we are in the 6th semester. We should know in depth, right? So will whatever program I write, will it be loaded into the main memory or it will be loaded into your RAM? Is that the work of the loader? No. Loader's work is to load the assembled or the machine level language program or your object program, which means whatever program I write, it has to be compiled. Only the compiled object code will be loaded into the main memory for execution. So who will do that loading? That loading will be done by the loader. That's it. Right? So loader has to load the object code into the main memory. Right? Next thing is macroprocessor. So macroprocessors you would have actually studied already. What do you mean by macroprocessor? Macroprocessor you can just relate to functions, right? So especially I would say you relate it to your inline functions in C++. So what they do is, wherever there is a macro call, so macro call is function call. Let me say there is a function called sqrt is my function, but wherever I say sqrt of 4, I have to find out the square root of 4. So what happens is, whenever a function or a macro, okay, is found, whenever there is a macro found in your program, it has to be expanded. So what do you mean by expanding? You have to, whatever definition is there for sqrt or whatever function you have written for sqrt, that function has to be replaced inside the program. That function has to be expanded inside the program. You understand? Yes. So that is called as a macroprocessor. Macroprocessor here are functions. So whenever you find a function call, usually what happens, how does a function execute? Let us say in C++ or C programming, How does a function execute? If I see a function fact of 5, so fact will be a function which you have written. Your cursor will be transferred to the fact function. It will pass this parameter 5 into the n value. That parameter will be passed inside that function, and then those steps will be executed. Once the function is executed, it will come back to the main program. Even microprocessor subroutines work like that. Your control will be transferred, but macroprocessor doesn't work like that. So you controlling a transfer is going to be more work. Okay, it's called as a overload. So we don't want to do that. So what we will do, we will just, wherever you see that function, you will copy and paste that function's coding, okay, inside the main program itself, so that the cursor doesn't have to be transferred. So that is the work of the microprocessor. Compiler we saw. Operating system, of course we know, this is also one of the components of system programming. So you know that what is the work of the operating system? It has to do memory management, file management, process management, disk management. We have studied enough of all of that. Yes, so these are the 5 components. So if it is a 2-mark question, just list them. So assembler, comma, loader, comma, microprocessor, compiler, operating system. Just list, it is enough. Right? Yes. Here you also should know some terms. Before entering into the subject, I want you to know what is what. Right? So there is some things which you should know. Right? So I told you that whenever I write a program, that program has to be first compiled or assembled. Whatever it is, it has to be converted into machine level language. That object code has to be loaded into the memory for execution. This is the plain and simple process which is going to happen. Right? So who will help you in executing the program? You have all these things. So your operating system will help you, your assembler will help, your compiler will help, okay, your macroprocessor is going to help, your loader is going to help in the whole execution of the program. These are the things which will play a major role. Right? So for this process to happen, you should remember, you should know some things. Right? So what is that? Is first one term you should know is called as allocation. First term you should know is called as allocation. So what do you mean by allocation? Okay. So what you should now know is, whenever I am writing a program, I just consider, or say, let us say that is my assumption. So I am going to assume that all my program I write, I want to start with memory location 0. Right? Because, so that is an assumption. Why? Because whenever I have to move to the main memory, so that time the address is going to change anyways. Right? So when I am writing a program, I am just writing a program line by line. I am going to save it as a C program, and then I am going to compile the program. Then the loader is going to load the program into the main memory. When the loader is loading a program into the main memory only, you will come to know in which memory location it is going to be loaded. Until then, you don't know what is the starting address. So I just assume now that 0 is my starting address. For all the programs I'm going to write, I'm going to assume that 0 is my starting address. So first thing you should know, the assumption here is 0 is the starting address for all the programs, and this 0 address is a relative address. This address is known as a relative address. Right? There is another address called as an absolute address. So what do you mean by an absolute address is, so for example, so let me go to the example and show you and come back to the slide. Right? Say this is a program, sample program. So we will go to it, we will see what this program is all about. Now, as I told you, see this relative address, the middle column you see, the relative address is, we are assuming every program I write is going to start at the relative address 0. I will start at relative address 0. So depending on the size of that particular instruction, so if it is 2 bytes, 4 bytes, 6 bytes, depending on the size, I will have the next line number. Say, let us say it is 4 bytes, then for 0 it will be, first line will be written at memory location 4, second line will be written memory location 8, and so on. Here every instruction is going to be 4 bytes. So we are going to start from 0, 4, 8, and so on. So these are going to be memory locations actually. But this is an assumption only. That is why you call them as a relative address. Okay. But there is something called as absolute address. So how will I get the absolute address? Is only when the program is loaded to the main memory, we will get the actual address where the program is going to reside. Where the program is going to reside. Right? For example, here I am assuming that my program is going to be loaded at memory location 48. Just assuming that I am loading the program into the main memory and that the starting is going to be 48. So what happens? So now 48 will be the first line plus 4. 52 will be the second line. 56 will be where the third instruction is going to be stored. Why? Because each instruction needs 4 bytes. So this address, so where the actual program is going to be stored in the main memory, is known as your absolute address. right? This is known as your absolute address, right? If I know the starting address, see 0 is what I'm starting, right? If I know what is the starting address, what is starting absolute address, right? In this case it is 48, which means I can easily calculate 48 plus 0 first address, 48 plus 4 second address, 48 plus 8 third address, 48 plus 12 fourth address, and so on, right? So that is the only thing. If I know the starting position of the first line where my program is going to be stored in the main memory, then with that, and I can add that address to the relative address, and I will be able to find out where my program, where every line of my program is going to be loaded in the main memory, right? So that is why we have two components here. One is called the absolute address, other one is called the relative address. So what is the assumption here? We have written the program. When we have written the program, we have written it in, say, for example, we have written it keeping in mind the relative address, where we just assume that it is going to start from 0, right? So here I am saying, I am writing this program. This is the code when I have written the program, right? I have written the program. The next step is I will compile, I will assemble this program. This is an assembly level language. So I will assemble this program. Then I will load the program into the main memory. Right? So when I write any program, I will start at location 0. Right? Now here when I'm just saying I will be loading that compiled program into the main memory for execution. So now what I should do, I should know what is the address allotted to me. Who will allot it? Operating system is going to allot me one address memory location where I can load my program and execute. Right? So let us assume it has allotted address location 48. Can it be different? Yes. This is just an assumption. You can keep any address. So why 48? It is difficult. I will keep it as 50 so that adding will be easy for me. Yeah, you can do it. Right? No issues. Right? So this is going to be the starting address. So if I only know the starting address, I don't have to know all these addresses. So I don't have to know any of this address. Only thing what I should know, if I know the starting address, I will add the starting address with the relative address. Then I will get what I want. What the actual address is, I will come to know. You understand? So this is the basic concept. Right? What am I actually doing? Right? For that, you should know these terms. Right? What are these terms? First one is called allocation. So allocation means allotting space in the memory for your program. Right? So I have compiled the program. So I'm going to say I wanted to execute the program. So memory space will be allotted for your program. That is called allocation. Right? Simple. Just allotting memory space for you in the main memory so that you can execute your program. Right? Yes. We will come back to linking and relocation. Next one I wanted to explain is loading. So what do you mean by loading? Physically transferring your program, compiled program, into the main memory. Physically transferring, which means copy and paste it in the main memory. You are going to transfer the whole program to the main memory. First space will be allotted, that is called allocation. Once a space is allotted, the program has to be loaded into the main memory. But in between, there are some steps which you should know, which you should understand what is that. For example, linking. What do you mean by linking? Right? So whatever variable I am using, whatever function I am using, could be a library function I am using in my program, I should know where, in which memory location those things are there. Only then I will be able to execute the program successfully without any hindrance. So how can I get that? I have to do a linking. I should link. Every unknown symbol has to be resolved. Okay. What do you mean by unknown symbol? For which you don't know the address. So I have loaded the program. I know where every instruction is. But I don't know where these variables are. For example, variables, the functions, the libraries. You don't know where they are. Right? Only if you know them, you will be able to do the linking. Right? So how will we know that? I have taken one example which is from the loader. So don't get confused. I just want you to understand the concept. That's it. Right? I'll show you that example. From that you will be able to understand what actually we are doing in linking. What is that we are doing in linking? Yes. Okay. Yeah. Don't faint. It's not a difficult thing at all. This is an example given. I could have used a very, very simple example also. But since you will also be studying this direct linking loader, this example you're going to study, I thought why to have another example and confuse. So we will take the same example. Only the variable names, the program names are little very it's like an abbreviation, right? That's the only problem. Otherwise, I think it is very simple to understand. I will tell you what it is, right? Let us start. Let's break this program, right? First thing is, I have written a program. The name of the program here is known as VG1. So I have written a program. the name whose name is going to be PG1, right? So just take a pointer. Right. So this is the name of the program. The name of the program I have written is PG1. So what I should do, I have written the program. Relative address is starting from 0, right? It goes on, let us say, till 60. So 56 maybe it is 4-byte instruction or 4-byte value declaration actually has happened. Whatever it is going to go from 0 to 60, let us say. Okay, this is a program whose name is PG1, right? Yes. What is the problem now for me? The problem now is, in my program, I have declared variables. I have also have functions, some function declarations are also there, right? I have also used some functions which is present in some other program, right? Let us say it's like a library. I'm going to use math.h, I'm going to use square root. So what happens? You have to load the math.h program also into the main memory and then execute the square root function. You understand? So that is what we are going to do here. Instead of saying my program is to find the square root, I'm using math.h. I'm just saying generally I have a program PG1 which is going to use another program which is called PG2. So I have one program PG1, it is going to use variables and functions from other program also, right? So what happens, what I should do, I have written this program. So PG1 is here. There is another program PG2, let us say, another program, that program also is written from 0 only, again relative address, right? So I have to load these two programs into the main memory. So what will be the address of all these instructions is what I wanted to know. What will be the address of every instruction, right? Yes. I also have another information saying that this particular program is being given a memory location of 104. I can load this program at the memory location 104. At 104, I am loading the program, right? Yes, I keep loading. I finish loading, right? Then the next program, from the very next memory location, I will be loading the second program also, right? So for executing the first program, I need the second program. So first I loaded PG1 program at location 104. Then I will load PG2 program. So obviously it will be at location say 168, right? I'm going to load it from location 168, right? So one more thing you have to understand, in IBM 360 or any programming language, first the program will be written, right? Here you can see that the program is written. Yes, in the program whatever variables are used, right, those variables are declared after the program. So from 0 to 40 the program is written. From 40 you have the data present. The data which you need in the program is present, right? So don't worry about the start, entry, extend. This is all concept of direct linking loader. I'm not going to touch about it. Just showing when I'm loading the program, PG1 is where what a program I wanted to execute. I will load at location 104. That also uses PG2. So I'm going to load PG2 at location 168. Right? At 168, after PG1 is done, stored, the program is stored, I will be loading. This is what I'm saying. Right? Now, just look into these two circles, whichever I have drawn here. Right? Just we are only going to talk about that. Right? What do you mean by linking? What do you mean by linking here is, I am saying there is going to be a variable. Say for example, PG1 is my program. It is going to have two functions. It could be a variable or it could be a function. So whatever it is, I wanted to know what address it is present, right? For example, PG1ENT1. Okay, it is some name. Let us say it could be a variable. Let us take it and there is a variable. It is going to be at location 20. There is another variable at location say 30. So this is how my program is placed, right? You can also have it as a function. The PG1ENT1 can also be a function definition. Whatever it is, I wanted to know what is the address of PG1ENT1. What is the address of PG2ENT2? Because these two symbols are unknown. I don't know. I know start, I have heard of start because it's all keywords, I know, but these variable names I don't know because you have to resolve the symbols. Unknown values are called as symbols which has to be resolved. You have to find out the address. How will I find out the address? Yes, for example, I have started the program at 104. Okay, PG1ENT1, here PG1ENT1 is at location what? 20. Your relative address is 20, which means what will be the actual absolute address? Yes, exactly. Your absolute address for PG1ENT1 will be 124. How is that? 104, right, is your loading address plus 20 if I add, then you will get your address for PG1 ENT1, right? So now we have resolved the symbol. We know the meaning of it. PG1 ENT1 means 124. We know that, right? We have found that. This process is called as linking. Yes, this process is called as linking. Similarly, PG2ENT2 is nothing but 134, right? So we will add the what value? First base register value. We call it as a base register value because the starting point of the address, your main memory address, is going to be loaded in your base register. That we will come back to that again. If you have doubts in that, I will come back to that. So when I add 30 with 104, I will get the absolute address of what? PG1 ENT2, right? So I have resolved. In my program, say for example, I am using it like this. I wanted to find out, this is like an assignment for you. Find out the address of PG1 ENT1. So what is the address of PG1 ENT1? 124 is the answer. So PG1 ENT1 address is going to be 124. We have found that out already. Again, there is an assignment which is going to be find out the address of PG1 ENT2. So PG1 ENT2, what is the address? You have to find out. How will you find out? PG1 ENT2's address is 134 plus 50. So PG1 ENT2 plus 50. So 134 plus 50. What is that? It is 149, right? The next one, you have to find out the address of PG1 ENT2. PG1 ENT2 is 134 minus PG1 ENT1 is 124 minus 3, right? 134 minus 124 is 10 minus 3 is 7. You understand? So now you know all the values. You have resolved all the symbols. You know where that symbol is going to be stored in which memory location. If you are able to do this, then that's it. You have done the linking part. So linking could be linking your variables. It could be linking your functions written. It could also be linking your libraries. Okay. Mainly linking, we always say it is linking the libraries. Right? How is it linking? This is how it is going to link. Now we will take the next, go to the next thing, address of PG2. So you should not only be aware of where PG1 is stored, you should also know where is PG2 because PG2 also is going to be used in this particular program. So address of PG2. Address of PG2 is what? 168. So here the address of PG2 here is going to be 168. Right? So PG2's address is 168. Next one. Address of PG2ENT1. So PG2ENT1 means PG2 programs. There is some variable or a function. What is that address? It's here, it says 16. Right? So what is it actually? 168 plus 16. It is going to be 168 plus 16. That is an address of PG2ENT1. PG2ENT1 is 168 plus 16. Right? Plus, what is it? I am using PG2 program itself. Where is PG2 stored? PG is stored at location 168 minus PG1 ENT1 plus 4. PG1 ENT1 is here, which is 124 plus 4. So you do the math. What you will be getting is 232. Why are we calculating these addresses? We are just understanding, has my linking done perfectly? Is there any loopholes in between? Am I able to find out addresses of whatever I want? Yes. Yes, I am able to find out the addresses of whatever variable or function I want. This process is called as linking, right? So when we come to this program, we will see, okay, we can even have a better understanding of that program. But now just to understand what is linking is what I have told you. Linking will resolve symbolic references. So what is symbolic reference here? Symbolic reference is nothing but you are breaking these names, unknown names like your variables, right? Like your library functions, all these things you are going to resolve and find out the address of them. That's it. Right? The next one is called relocation. Right? So what do you mean by relocation here? So here, so we have told unknown symbols. Yeah, we have done it. But what happened to the memory locations? So let us show you. I'll show you one example here. In this particular program, I'm saying here L, which means load, right? 2,904. I'm using an address here. Right? 904 is an address. What is 904? 904 is a relative address. So what you should do? You should also do the relocation for that. Which means you should know what is the now what is address. What is that now? After loading into the main memory, what is the address? The address in the program I told it is 904 is what I have given. Can I just say 904? When I load it to the main memory, what happens? It will become a error. Because 904 will be some other instruction. Okay. So what I should do? I should change wherever there is 904, it has to be replaced with 952. Yes, wherever I am using this address, I will be replacing it with 952. Why? Because that is the actual address. That is an absolute address, which means the address after you load it to the main memory. That is the address after you load it to your main memory. Right? So this process is called as relocation. Right? Adjust all the address dependent locations, which means in my program, if I am using addresses, wherever I am using addresses, that has to be again converted into, from relative address, it has to be converted into absolute address. Right? So in my program, what all I have done, first of all, I have allotted memory to load the program. Then I will search for all the symbolic values. I will find the address for all the symbolic values. That is known as linking. Right? The next thing I will be doing is relocation. So what do you mean by relocation? I have to find the addresses, the relative addresses, wherever it is there in the coding. I have to change it into absolute address. Right? So what I will take care, I will adjust all the address dependent locations. So whichever location is dependent on the address, that I have to relocate. Right? So these things we have done. Now my program is ready. I know all the values in the program. So when the program is loaded into the main memory, I will be able to easily execute the program without any errors. Right? So these are the four important concepts you should understand: allocation, relocation, loading, and linking. Right? So loading is physically loading your program into the main memory. I have told you already that. Yes, clear? So once you understand this basic concept, then whatever I say, you will be able to relate to it. Okay, next we will continue with some 2-mark questions. Here there are some important 2 marks. You can see your old question papers. First 4 questions, right, will always be from this chapter only. So all these questions, whatever we are going to see now, 2-mark questions are important, very simple also. But it is very difficult to write 4 points. So you know that basically you know the concept, but writing 4 points, it may be difficult. So remember, try to remember the points. Right? So what is a procedure and what is a processor? Right? These are 2 different things. You cannot compare them actually speaking. It's like comparing apples and oranges. But still, so this is a 2-mark question which is frequently asked. A processor is a hardware. Yes or no? It's like your Intel chip. So let us say i5, i3, i7. So these are the processors. Okay, so it is going to be in hardware. Okay, what do you mean by procedure? Procedure is a function written inside your program. Okay, a program is there, and inside a program you will have small procedures or functions. So that is known as a procedure. So that is nothing but your software program. Processor basically is hardware, and this is going to be software. So other differences you can easily write. So you just have to understand what is the basic of what do you mean by a processor, what do you mean by a procedure. Right. Next question. What is a processor and what is an I/O channel? So what is a processor? We already saw. Right? What do you mean by an I/O channel? Right? So whenever I have to write the coding, I should also understand the processor first. To know what registers are there and all, I have to understand the internal components of the processor. So what is the work of I/O channel? The work of I/O channel is it's going to interact with your I/O devices, input device and the output device, that is going to fetch the data into your system. Yes, it's going to be an intermediator who is going to take the, say, inputs and output from your input-output devices, and then it is going to pass to your CPU. Right? It's going to pass it to the processor. Then the processor will process those instructions. So this is the work of your I/O channel. It is just going to be an intermediate which is going to gather or say receive and send data from your input and output devices to your CPU, to your system, to your computer. So that is the work of your I/O channel. So this is another important question which is frequently asked. Yes, here. So this one you should understand. Closed subroutine and an open subroutine. Yes. What is a closed subroutine? Here I am saying you can relate to a function. We have studied subroutine also in microprocessor, but still I will tell you can relate to a function. It is just a function. A closed subroutine will be stored outside the main routine, which means it is a function. It is not stored inside your main program. It is going to be stored separately. So whenever there is a function, let us again take the same example, sqrt or fact of 5. What I should do? Whenever fact function is going to be there in your main program, your control or your cursor will be transferred to that fact function, execute that function, and come back to the main program. Yes, this kind of subroutine. This is the usual procedure. Yes, in any programming language. This concept is called as closed subroutine. Right? So, but in macroprocessor, you have studied that the function call will be expanded. Yes or no? So, we will see that. So, what do you mean by open subroutine is something like your macroprocessor. Okay, or I would say I will relate it to your inline functions in C++, right? So what happens whenever a macro definition or a function is spotted? So let us say there is a function in your main program, it is sqrt. Instead of transferring your cursor to the function, what I will do, I will copy the function and paste it here. So what happens, sqrt a function or your fact function will directly be written inside your program. It is like your inline function, that is called as your open subroutine. So because of doing this, there are a lot of other things also which is going to happen. For example, in closed subroutine, since I'm transferring the cursor, it is going to be what? It is going to be seen as a HUD, like what do you say, overhead. It's going to be seen as a overhead, or the transferring process it's going to be time consuming, and it's going to consume a lot of space also, right? So that is going to be the problem. Whereas open subroutine, you can copy paste. But again, the disadvantage here is, what is the point in writing a function then if I have to again every time copy paste? How many ever times I cannot repeat the code? Here function itself is the concept of function itself is that you will minimize the code. You can run only once you write, it's enough. Every time we can go there and execute. But here that is going to be that's going to be beaten. So you have to just know what are the differences of this. Basic concepts, if you know, you can always see what are the various points listed out here. Next one is interpreter compiler. So this difference you have studied from the scratch. Both are translators, which is going to interpreter is going to translate line by line, whereas compiler is going to translate the entire program all at once. Yes. So what is the advantage of using an interpreter and what is the advantage of using a compiler, and which are the programming languages interpreter is used, which are the programming languages compiler is used? So this is what you are going to list it out, and that is going to be difference between interpreter compiler. This also could be a 2-mark question. Yes. Yeah, this multi-processing and multi-programming. Yes, this term is usually confusing, right? Since we studied multi-programming in operating system, we will first start with multi-programming. So what do you mean by multi-programming? Yes, so there is only one processor, right? It has to execute your program. So when I'm using one processor, only one program it can execute at a given time. At a given time, one processor can only load one program and execute. Okay, but that is going to be time consuming. So what I did in operating system, I did something called as scheduling. So what I will do, I will, when this particular first program goes for IO operations, I will load a second program and execute. Once that finishes the IO operation, I will execute the first program, and so on. For this process, what I did is called as multi-programming, which means programs are multiple, processor is only one. Okay, remember like this. Programs are multiple, but only one processor is there. So I am going to juggle with that only. One processor keeps switching between programs. That is called as multi-programming. What is multi-processing? Processors are multiple. So now we have come to an age where one program itself is so big, okay, and so complicated that one processor is not enough. Right, I'm going to use different very many processes. You have this quad core, octa core processes where I'm dividing the program and trying to run the program simultaneously. So more than one processor will be there. That is multi-processor. You understand? So this is again 1-2-mark question. Yes, so that's it. I think we have covered most of the basic concepts today. When we start the actual classes, so you will find you must be able to relate to these concepts. Any doubt, you can always send me a WhatsApp. I will take that question and maybe reply it to you in the next class, right?